Okay, this is part D of this question. We have x40 and we want to build this x40 using xt. Again, I try to partition x40 into different parts. Then for each single part, I try to find the expression for that part based on xt. If I can do that, then I can build x40 just by adding all those partitions together, the expression for all those partitions together. Well, this signal, I would say this x40 has three main parts. The large part is here, this large triangle here, which is quite similar to what we draw in part A of this question. We have a small triangle here, and we have another small triangle here, and since it is symmetric to this vertical line, then I would say it is enough to find the expression for this little triangle here, or this one here. Then the other one would be just the inverted version of that signal. I mean, for example, if I find the expression for this one in the right, this small triangle in the right, the left one would be just the inverted version of the right one. Alright, so let's start with this small triangle here. Let's start with this one. Well, this is pretty much similar to the signal here. I would say maybe we need to flip this xt, this signal over this horizontal axis. Okay, so if I do that, then we would have a signal like this. All right, and this is minus x of t. Okay, this one is more similar to what we are looking for, to this signal here. But you see that the amplitude of this signal is also much smaller than the amplitude of this signal. Oh, let me try it here. If I look at the amplitude here, it is -1. I want the amplitude of this signal to be -1/3, so I need to scale down the signal, and to do that I need to multiply 1/3 to this signal. Then I would have something like this. Okay, this is more similar to this signal. This is more similar. So then the amplitude would be almost -1/3. And to get this signal, as I said, it is enough to multiply this one to 1/3. So we would have -1/3 x of t. Okay. But if you look at this signal on the right, if you look at this signal here, its width is almost half of or exactly half of the width of this signal here. So I need, if I want to get this signal, I need to compress this one here and to reduce its width by half. Okay, so to do that, to compress a signal, we should actually multiply this t by alpha, and since I want to make it half, I need to actually multiply this t by 2. So we would have a signal like this. Or I can draw it like this. This is 1/2. And this green one, the expression for this green one is -1/3 times x of 2t. Then you would have a signal that it's width is half of the signal xt. Alright, so almost we get all we need. The signal here is also shifted in time to the right. It's been shifted to the right. Okay, if I want to get a more similar signal, I need to shift this one as well, shift it to the right. So how much should I shift it? Well, I should shift it by this is 1 over 2. It should go to it should move to here, where at point t equals 2. So if I want to shift from t equals 1 over 2 to t equals 2, then I should shift this signal by 1.5. Okay, so if I do that, let me use a different color, maybe this one. Well, the signal is minus 1 over 3 of x of 2t, and I want to shift this by 1.5, then we would have minus 1 over 3 x of 2 times t plus, since I want to shift it to the right, I should reduce 1.5 from t, so t minus 1.5, and instead of 1.5 I can write it 3 over 2. Okay, this is 1.5. And if I further expand this or simplify this, we would have minus 1 over 3 times x of 2t minus 3. So this is the expression for this signal here. So I would write the expression here. The expression for this is minus 1 over 3 x of 2t minus 3. And we saw that how can we build this little triangle here step by step. Alright, as I said, this one here is the inverted version of the signal, the triangle in the right. And you know that if we have a signal, say xt, and I want to invert that over time, then I should replace that t by minus t. Okay, if I do this here, then I can say the expression for this signal here is maybe you can use different color for the signal here. The expression is minus 1 over 3 times x of minus 2t minus 3. Alright, what is left is this triangle here, the large triangle here. We already got the expression for this signal in part A of this question. Okay, we got this already, and the expression for this was x of t plus 1 for this left part plus x of minus t plus 1. All right, you see that the red triangle, the large triangle, this large one, is kind of actually the expanded version of this green one, and it's been expanded by well, I assume that here is 3 over 2, and here is minus 3 over 2. So the signal has been expanded. If we want to expand the signal, as I said, if we want to expand the signal of xt, it's enough to multiply t by alpha. Okay, then you would have x of alpha t. And if alpha is between 0 and 1, we have the expansion If alpha is larger than 1, we have compression. And generally, if I want to expand a signal, say if I want to expand xt so that point 1 moves to point 3 over 2 or 1.5, then I need to set alpha equal to 1 over 3 over 2, and this is 2 over 3. That means if I want to do such expansion, let me write it down here, I should replace xt by x of 2 over 3 times t, okay? And for this signal, I should replace that by, or I can say this red one here, yeah, I can use the same color. I can say this red triangle here is the expanded version of this by replacing t by 2 over 3 times t. So this is x of 2 over 3 times t plus 1 plus x of minus 2 over 3 times t plus 1. Okay, so I think we've got all we need. So I can finally write x4 I can write x4 here. So x4 t equals this part, I would say part 1 plus part 2 plus part 3. So for part 1 we have minus 1 over 3 times x of 2 times t minus 3. For part 2 we have minus 1 over 3 times x of 2t, minus 2t minus 3. And for the third part we have x of 2 over 3 times t plus 1 plus x of minus 2 over 3 times t plus 1. So this is the expression for x4t, all based on xt.